Today we're going to be looking at all the different ways that you can plot lines on a coordinate grid. And the first of which is going to be if a problem provides you with the x and y intercepts. What's important to remember is that an intercept is where the graph crosses an axis. So the x-intercept is where the line crosses the x-axis, and the y-intercept is where the line crosses the y-axis. So if we want to go ahead and plot these points, if our x-intercept is at 2, we're just going to go to 2, put a point there, and our y-intercept is 3. So we're going to go ahead and put a point there, and then we are going to connect them with a line. The next method of graphing is using a line that's written out in slope-intercept form. This is your general slope-intercept form where m is your slope and b is your y-intercept. So this equation says that y equals 1/2 x minus 1. So comparing this to our general slope-intercept form equation, 1/2 is our m, which is slope, and -1 is our b, which is the y-intercept. So just like we did in the last problem, we're going to go ahead and plot the y-intercept. So we're going to put a point at -1, and now we want to plot a few points using the slope. And what's important to remember about the slope is that when it's in fraction form, it's rise over run, which means that this is going to be our y and this is going to be our x. So if we are going, this says that we're going to go up 1 this way and over 2 in the positive direction, both ways. So we're going to plot a point here. And then we're going to do it again. You're going to go up 1 and over 2. Plot a point there. And then we just have to connect them with a line. Things can be a little bit trickier if you're given a line that's written in standard form. This is your general standard form equation, ax plus by equals c, where a, b, and c are all constants. Say we have the equation 3x minus 2y equals 2. The best way to go about graphing this line is to first manipulate it and put it into slope-intercept form. And remember, slope-intercept form is y equals mx plus b. So what we're going to do here is solve for y. So the best way to do that is to subtract 3x from both sides. So we have -2y equals 2 minus 3x. And then we're going to divide everything by -2. So we have y equals -1 plus 3/2 x. So now, comparing this to our slope-intercept form equation, 3/2 is our slope, and -1 is our y-intercept. So going ahead and graphing this, we're going to have point at -1, and then because our slope is positive, and remember it's rise over run, we're going to go up 3 over 2, point, and then up 3 over 2, point, and then just draw a line. Now say you're just given the slope of a line and a point that it passes through. This is pretty easy. What we're going to do is we're going to start by plotting this point. So we go -3 on the x-axis and +1 on the y-axis. And then we're just going to use this slope to graph from that line. The important thing to remember is that when you have slope that's a whole number, this is always over an imaginary 1. So that means that our rise is 2 and our run is 1. So we're going to go up 2 in the positive direction over 1, point, up 2, over 1, point, and draw a line. What if you're given something like this, where it's not really an equation, it just tells you what one of the variables equals? That means that these are going to be straight lines, either vertically or horizontally. So let's look at this first one, where we have x equals 3. This means that no matter what your y value is, x is always going to equal 3. So of course, x is going to equal 3 at the x-axis, and then as we go up, it's going to keep equaling 3, but also as we go down as well. So that means that we have here a vertical line at x equals 3. And now looking at the second one, where y equals -1, it's similar, but it's going to be horizontal. Y is -1 at the axis, but also no matter what the x value is, it's always going to be -1 for the y value. So that means that this is a horizontal line at y equals -1. So I know that's probably lots to take in. Why don't you go ahead and take a second to practice, and don't forget to come into drop-in tutoring from 6 to 9 p.m. on Sundays through Thursdays if you're needing any extra help.